So yes, Brandon Baker, tech lead for cloud security at Google. Today I want to talk about our philosophy, our approach to internal production security at Google. This is really the first time we're talking about this. We recently put out a white paper on this topic in December, and this is going to be an approach and a walk through some of the history, the rationale, the problems, and how we've addressed these problems for security at Google. So I'll talk about the background, the problems, the history. I'm going to go through and talk about some differences between traditional infrastructure and sort of this modern sort of cloud-native security infrastructure that we've implemented in production at Google. Walk through some of the details on how those systems work, and then sort of wrap up on how this is applicable outside of a place like Google. So to start thinking about the problem space that we have to work with at Google, we have to think about how we can manage security when we have thousands, tens of thousands of developers deploying several billion containerized workloads every week, with many products that have a billion users. And how can we manage security for these at scale, repeatedly, and consistently, even in light of problems like this, Heartbleed, right? Flaw in OpenSSL that allowed somebody to extract data if they could connect to any server that did TLS termination running OpenSSL. Or things like this, shell shock. If you remember this one, this was remote command execution through bash shell escape. It was actually fairly prevalent. A lot of software included libraries that allowed somebody to access this vulnerability. Or things like this, a little more recently, TCP SAC, that was a panic and potential DOS and maybe even exploitation in the Linux TCP/IP networking stack. Or things like this, Meltdown, Inspector, and Foreshadow, and so on, right? CPU side channel vulnerabilities. And if we think about what these things look like, we're in a space that has really moved way past concerns of viruses and worms and phishing to an environment where we have to be concerned about vulnerabilities in common software, common infrastructure, the supply chain for how software finds its way into production, and fundamentally even be concerned with flaws in how CPU and CPU isolation was supposed to work. So given those concerns, again, how do we do this in a way that's consistent and can deal with patching and scale that we have to operate? Oh yeah, and then there's one other problem too. We have to do this without actually having there be noticeable user impact. Right? So to get there, first we have to agree on a few things. Servers are cattle, not pets. Right? The whole idea for this, and to make this really work at scale, is that no one server, no one machine is special. And you don't have a different type of machine for different types of workloads. They're all interchangeable. There's just one sort of compute fabric, and things can move around. Things do move around all the time. We also have to agree that security doesn't end at the network edge. Just because something's past an edge ACL, a firewall check, some IP check, or connected in through the VPN, doesn't mean that it's trusted. Right? Okay, so this is getting to this idea of a zero trust environment where just because somebody is present on the network, we don't trust them. In fact, if they're just on the network, we really don't want to trust them. We also have to agree that developers shouldn't have to be security experts. And what that really means is that we don't want developers to have to be concerning themselves with all of those vulnerabilities and patches and security issues I just mentioned. We don't want developers to have to be concerning themselves with what's the right certificate policy that I should be setting and enforcing. Right? That needs to be part of the infrastructure. It needs to be outside of what developers have to be concerning themselves with, because we want them to be productive and efficient and not all have to be security experts. We also have to agree that workloads shouldn't be the place where we enforce security policy. Right? Every time I want to update, going back to that SSL policy, I shouldn't have to push out new versions of my workload to change that I want to start enforcing perfect forward secrecy on certificate checks, for example. And the last thing is, to make this kind of work and work at the scale that we operate, we need all workloads to be run as containers, really without exception. And I'll get into kind of a little bit more what that means in a minute and why that's so important for security. It obviously has huge benefits just for deployment and workload management. but there's a security angle here too. And so if we step back for a minute, back in 2014, we published this idea in this white paper called BeyondCorp, which at the time really looked at the changing environment for how people were and where people were doing work for any sort of an enterprise, Google included. And on BeyondCorp, the key assertion for BeyondCorp was that the traditional network model no longer applies. Right? The perimeter is not just the physical location of where people are or where the enterprise network is. And just because something's inside the perimeter doesn't mean that it's blessed or a safe place to be or to host computing devices. So really, the idea with BeyondCorp is let's move past the network and let's think about not identity as where somebody is or what network port they're plugged into or what their IP address is, but think about who the end user is and what's the security state and attestation of the device that they're using to access the network. And so if you think about taking that model and kind of thinking about these problems and how we're addressing them for production, it's really a very similar idea. I mean, if we just simply replace the enterprise with the data center, replace personal computing devices with workloads and servers, right? This is kind of informing kind of where we're getting to this idea for BeyondProd. So now let's get into some of those details. I mentioned containers were really important to the model. The quick idea for a container is that a workload is deployed with all of its dependencies packaged together, all of the libraries and other things it's going to include, and the intent is that that container workload itself is immutable. Right? You don't patch the container once it's been deployed, you build a new one and you push that out in its replacement. Another key important aspect of how we've developed and structured services at Google is the idea around microservices. This is taking a larger, sort of traditional or more monolithic application and breaking it down into smaller pieces and deploying and managing those things independently, but building up trust and policy that describes which microservices make up a larger identity, or which ones are allowed to talk to each other and which ones aren't. And so we found that when you combine these two things together, because we can break things into smaller pieces, we can also patch and deploy much more frequently, much more easily. And we also can understand what we have and what it depends on, and when somebody's using OpenSSL, where that exists. And so the idea of kind of these things all combined is often referred to as going cloud native. Really what it is, it's informed by our history in developing and running cloud services, but I think it's really applicable to any environment, whether you're deploying 100 containers or a billion containers. So we think about the migration and sort of what a traditional security infrastructure looks like and kind of what this cloud native infrastructure model looks like along a couple dimensions. If we think about it along the network dimension, the traditional model might look something like you've got perimeter-based security. It's about firewalls, it's about IP whitelists and blacklists. But communication once somebody's passed that firewall might be regarded as trusted. Cloud native model, it really is this idea of zero trust, where when we talk about zero trust, we mean that because you're present on the network, you're sending packets around, that isn't good enough. That isn't actually anything that will confer you any sort of trust. Okay. And if we think about identity and the idea of like service or workload identity, a traditional model might tie identity to where something's running, right? So, oh, it's the database server, and it has this IP address. Or, oh, it's the CRM application, and it runs on these machines that have these IP addresses or these names. Okay. In cloud native model, because we're containerized, using resources much more efficiently, moving things around, you can't tie any notion of identity or policy back to the machine. Right? It has to come from somewhere else. It has to come from some other inherent idea of workload identity and not server identity. We think about kind of where the security policy and security requirements get baked in. A traditional model might say, I mentioned before, like that the policy that the application is required to enforce has to be compiled in or built in, included with the application. The cloud native model says, look, we've got this shared infrastructure, and so we can have requirements that live outside of your workload, your component, that are enforced by other things that you have dependencies on. And I'll walk through a more detailed example of that in just a minute, what that looks like in practice. Rollouts, patching, obviously, is an important element of security. Traditional model might be because you've got a larger monolithic application made up of a lot of components and a lot of dependencies included in. And because you may perhaps have fewer instances of that thing running, it can be a lot more difficult to patch, or patching happens less often. In cloud native model, because we've got these standardized small things, we are essentially continuously patching. We also can do sort of a blue-green deployment model where you've patched some things and checked to make sure they still work right before you actually do a wider rollout. Rather than bring the whole application down, bring the new one up, we're doing this sort of constant update and patch cycle. A traditional infrastructure security model might look at the unit of isolation, right, for separation as strictly around the physical machine or maybe the virtual machine. Cloud native model, because we are bin packing and we're using things more efficiently and workloads are moving around, and because we often will see workloads from different services that end up co-locating together in the same physical machine, and because we're concerned about problems like where did the code come from, what if it's compromised, what if there's a CPU side channel, and we can't necessarily guarantee or rely on physical machine separation, we've really had to invest in stronger sandboxing isolation technology. There's something called gvisor that we've developed that's been reasonably effective against some categories of side channels, and generally as a mechanism for sandboxing workloads is something we found really helpful to take us away from having to rely solely on OS process isolation, which we sort of deem as not sufficient on its own, and give us several additional layers of security between workloads. So I want to take those principles, those properties, kind of walk through the life of a request for user data as it goes through production services at Google, and talk about some of the technology that we've developed to impose or sort of implement the different security principles behind BeyondProd at each step. This is the first time we've talked about some of these things externally. Some of the names may have been changed for the white paper, for the Googlers and ex-Googlers in the room, but I think you'll all understand some of the concepts too as we go along. So if we start at the left, at step one, there's a request, end users requesting data for something, Gmail or search or maps or whatever, right? And that request comes in and hits a Google front end. And the Google front end is responsible for TLS termination. It's responsible for TLS termination for all services at Google. Right? Different services at Google don't run their own front ends. The front ends aren't part of the services. These exist as a layer, as a service layer. And what that also means is that when it comes time to do things like change that certificate policy or push that update for something like Heartbleed or change from OpenSSL to Boring SSL, we have one place that we need to do that. And that all the rest of the applications and services and backends downstream don't have to be updated to get that security benefit. Okay. So the request ends there, but now the request needs to be forwarded on to the specific application that's responsible for whatever this end request is going to be. Okay. To protect those communications internally, we re-encrypt using something that we're calling here application layer transport security. And this allows us to do mutual authentication and protect the contents of the request, and also to identify both source and destination of the request. With that being protected, we can send this now on to the appropriate application front end. Right? The part of the application is actually going to service this request. One of the other things that we've done in order to essentially protect and reduce the data access behind a request is a requirement to take a live request and generate an end user context ticket, an EUC ticket. And this is something that's implemented by, again, a different service. This is a place where now we can enforce separate security policy around user and user access. Okay. So when the application front end then can request it over to the end user authentication service and prove that there is a live end user request and get that validated, it gets back this EUC ticket. And why that's important is we only want these application front ends to be able to then go on and request data for users who are actively using the service in the moment at that time. Okay. So now the front end at step 4 will now place the request back into the service backend for the storage system that's implementing whatever backend for storage that this front end decided to rely on. Again, microservices and decoupling of things, these aren't all the same thing. The application doesn't have its own storage. It uses other storage services. And so that request, in addition to being protected with ALTS, will also be forwarding along the end user credential ticket to show that there's proof of live user request here. And the storage service now will, in addition to validating that the request is coming from an application front end that it knows and is trusted and has been validated, that it also is passing end user credential for a live user request for the valid for the service. And only when these policies are checked and validated by that storage backend will it actually pull the data and send the data back into the front end that's necessary for the request. So the BeyondProd model, though, is not just about controlling access to data. It's also about controlling access to the binaries that then can access data. So really what I'd say here, it's not just about infrastructure, it's also about a development process. And the artifacts of this process make up something we call binary authorization. Right? We have binary authorization for Borg being the job management and scheduling system here. And this is another piece of the policy enforcement of not how and what applications can talk to which other applications, but who and how a developer at Google can induce a change or update a container or update an application in production. So to walk through what that workflow looks like, starting here at step 1, where we have a Google developer who wants to submit a code change. Well, the first gate is code review. Right? There's a requirement that at least one other developer, and usually more, based on having somebody who is a specialist in the language and somebody who owns the code base. So one or more additional people need to review and approve that code change. And once it's approved, it moves into a code repository. That's a central service that's run as a distributed code system. But it's not on their workstation, right? They're not going to be doing this build locally. They're going to be doing this build on a system that is itself another secure microservice setup. And this secure CI/CD, so this build and deploy pipeline will go through and build the binary, run validation tests, and then ultimately sign the result with this binary authorization information about how and where this was built. And so the resulting binary, the resulting container that comes along with it also is bundled with this binary authorization information, such that when we go to push this into production, right, the production services then that are going to be accepting the update or the new build or the new service will check and enforce policy around where and how this was built to ensure that it actually came through that secure system that I mentioned in step 1 and step 2. We also further can isolate the workload using gvisor, sandbox technology, so that the workload now, if it happens to be running inside other workloads on the same service, are protected from each other with additional layers of protection. Not every workload necessarily runs with gvisor. It depends a lot sometimes too on how and where the source code originated or on how much exposure or how much data processing risk it has. So if it came from upstream and we don't necessarily know where the code came from, or if it's doing a lot of MPEG encoding, maybe that's something that we're more likely to want to have to sandbox. Okay. So overall, those are the steps and the pieces that make up this BeyondProd model. And as I mentioned, it's about protection at the network edge, but beyond. Right? Zero trust is a really important element here. It's about no inherent trust between services. It's about having trusted machines, but we're running code with known provenance that came from somewhere, that we have some identity information about it. It's about choke points, places outside the workload, places where we can enforce consistent policy. And do that so across all services that are running within Google, not one by one. It's about simple automated change rollout, patch management. And it's about isolation between workloads that are running side by side on the same machine, doing things beyond just OS isolation. And for us, making this change required substantial changes over time across two major dimensions, both infrastructure and our development process. We approach these simultaneously and incrementally, but I think that the model overall that's described in BeyondProd allows for opportunities for taking pieces, right? Doing things in phases. Doing things where you could start from where you are today, pick one area, right, and build from there. While I think the full realization of the model and having all these pieces come together is the most powerful place to be, I think each one of the things and topics I've talked about are on their own effective at mitigating different categories of risk. So for us, the benefits that we've seen in sort of making this change and taking this philosophy and doing this BeyondProd model have been around strengthening the security of our workload deployments and communication isolation, about enforcing policy at choke points, about decoupling policy from workloads. This is really a lot about what just the bottom line of this is just making security something that's done everywhere, it's done up front, and it's not something that our developers have to be concerning themselves with day in, day out. Like, let them focus on building services, let's let the security people focus on the security concerns. As I mentioned, we've developed a lot of systems and services and tools to make this model a reality. We've open sourced many of these. So I mentioned about having application layer transport security and mutual TLS. I mentioned about TLS termination and having that reside outside of a workload. You'll find some of that in the Envoy open source project. You'll find the idea around having policy for which parts of a microservice are allowed to talk to each other and which RPCs are allowed, which ones should be blocked. That idea is core to something called Istio. Having this idea of binary authorization, having code provenance, where something was built from, having these checks as they go into production, is part of the Kubernetes emission controller. You'll see it showing up in things like Kritis, OPA Gatekeeper, and we do have binary authorization for Kubernetes as well. And that isolation piece, that strong sandbox, is something that we've open sourced a large portion of something called gvisor. There's a link here to that open source project. This is a large undertaking. There's a lot of concepts, there's a lot of material here, so we've been publishing white papers about BeyondProd, about a lot of the topics that are related to BeyondProd, binary authorization, ALTS, secure design for infrastructure from hardware and bootstrapping all the way up. We're also taking this opportunity with something called Anthos, which is really about taking this BeyondProd model, both for workloads and for security, allowing people to modernize both on-prem and cloud and hybrid cloud. And a lot of these concepts and ideas we're also building into Anthos to make it easier for people to adopt this kind of cloud-native type architecture in their own environments, wherever they may be. And with that, gonna wrap. I'd like to thank Enigma again for giving us an opportunity to start to talk more about what Google's security looks like from the inside. I hope you found that informative and look forward to questions. Thank you.